Hi, let me just quickly fix my lighting. Okay, hopefully that's better. Sweet. Okay, so I was thinking, first, thank you both, and I'll thank Alex when he joins us as well. Thank you for presenting your research. I'm really excited to hear what you have to tell us. So I was thinking we'd go in the order in which you were advertised in, or your talks were advertised in the newsletter, which is Rachael first, then Alex, and then Claire. Does that sound fair? Perfect. So I think Alex is just about to join us.
We're just talking about the order.
Yeah.
What was the order?
So the order is going to be the way that it was advertised in the newsletter, which is Rachael first, and then you, Alex, and then Claire to end us off. So I'm quickly just going to tell you I am. I am a postdoc here at U of I, working mostly on wildlife genetics, but I'm super into birding as well. And so I go by she or her. And I don't know if you'd like to take a second to just introduce yourself. Also, this is recorded, by the way. I should mention this as we start.
I guess I'll go first since I'm going to do the first talk. So I'm Rachael DiSciullo. I'm a PhD student at Illinois State University, and I study house wrens, which is what I'll be talking about today.
Awesome. Alex, do you want to just introduce yourself?
Sorry, I didn't know who was next. I'm Alex Giovanni. I'm a former master's student of Mike Ward's. I've recently graduated and now am pursuing my PhD at George Mason University in Virginia.
Awesome.
And I'm Claire Johnson. So I also went to the U of I with Alex. We miss him a lot. So I was in TJ Benson's lab, and I just finished my master's degree in May. And I recently started a job at the Natural History Survey.
Awesome. Nice. So let's quickly check if you all can share your slides. Rachael, do you want to try first? Yeah, that looks good.
Do you mind real quick? I just want to check that this video is going to work.
No, for sure. Go for it.
Can you guys hear that okay?
Yeah.
All right.
At least from my end, I can hear it.
Okay. I think we're good then.
Sweet. Alex, do you want to check your slides quickly? Looks good from my side.
So all you're seeing is my slides and not my notes, right?
No, and we see the transcribed part as well.
Okay, cool. Do you want that on, or do you want me to turn that off?
It's fine. I think I can also allow participants to request live transcription. So I think it's fine. It's actually useful.
Okay, cool.
Ooh. Claire, your turn.
That good. I'm showing you the end before the rest of my talk.
Yeah.
All right. Cool.
Cool. Have you all seen any good migrants yet, or is it still?
No, I'm a terrible birder. Like, I need to go out.
Same. I haven't been birding a lot recently. I think I went like 3 weekends ago to Homer Lake, and that was about the last time. But I'm hoping the bird walks start up this Sunday, so I'm hoping to join then. You know,
Cool.
see some good stuff. I see our president, Colin Dobson, is our president. CCAS is president, and he's been seeing some cool birds actually on campus. And I'm like, cool. Does he have a secret spot that he goes to? Because if so, then I want to know about it.
He just finds every random bird possible somehow. I think he's out all the time.
Yeah, I don't know if you have been birding with him, but he's like, man, I have such jealousy when I go birding with him, because he hears the bird first, right? And the bird's still very far away, and he's like, oh, that's that. And I'm like, I can't even hear it yet. Never mind see it. Yeah.
Yeah.
Beth is also like that, actually. Beth Jeter is also a very good ear birder, if that's a word. I think birding by ear, right?
Yeah.
I was frustrated yesterday because I was out at Lake of the Woods and there were flocks of warblers, but they were up in the trees and they were so far and they weren't making any sound, even if I could have identified them by sound. But I got a good look at a black-throated blue one, so that was kind of neat.
Pretty, yeah. Yeah, I think it's also probably really hard with all the leaves still being on the trees.
Yeah.
Yeah.
And they don't stay still, they move.
No. Yeah, and the warblers are especially right. They're especially jumpy, if that's the word.
Yeah, but they're back. So
it's really good. Yeah, I'm really looking forward to Sunday, like having a dedicated time to go birding with people that can actually tell me what birds I'm seeing, instead of me wandering around like aimlessly trying to still sharpen up my American birds.
Have you tried the new component of the Merlin app now that is like what BirdNet was, where you can like just put your phone up for the song?
I've seen it, but I haven't actually tried it.
Yeah.
Have you tried it? Is it useful?
Yeah, just once. Yeah, I thought it worked pretty well. They had another like separate app that I think they've just melded into Merlin now. And so I've used the other one more than I've used the new like component of it, but it works pretty well. It's pretty amazing.
I've downloaded it, but I have to work on how to use it.
Yeah.
Yeah, I have to admit, the photo ID from Merlin has been a close friend of mine.
Yeah, absolutely.
Cool. So it's like 3 minutes to, I guess we'll just wait a little bit more before I start with the just general announcements, and then we can jump into the
I was pleased I could find you by Googling the Champaign County Audubon Society. And then I guess your newsletter came up because I didn't have a link to the meeting and I was afraid I wouldn't get in.
Oh, I didn't realize, Beth. I thought they had sent out an ad for Kendeigh grants to the listserv, actually, to the Bird Notes listserv. But I might be wrong.
Yeah, well, I may just have missed it.
I'm glad you were able to find us. I hope more people join though. And we've also been advertising on Facebook, but you never know how broadly that will circulate. Some posts are like hundreds of people interact, and then some it's only like 20 people that see it. So we also have a Twitter and I don't know if we have it. Yeah, we have an Instagram account as well. And I hope they join. Megan Scripp and Sarah Johnson are the folks that run those. Hi, Roger. Just calling people out by name. I shouldn't be doing that.
Sorry, I meant to say, without being muted, I'm fine. How are you?
Yeah, good. Looking forward to getting the full migration happening,
Yes. Yeah, this Sunday.
Yeah, have you seen anything good?
Well, I had a few days ago, I had a black-throated green in my backyard, which was kind of weird. Other than that, nothing yet.
No.
We saw a bald eagle over the Wisconsin River Tuesday, so that was good. Looks
Yeah.
like Colin has turned into an avocet.
I'm getting my camera on. If it does come on, I guess it still hasn't. I don't know what's going on. I don't know if we figure it out.
Colin, I was telling them how jealous I am of you. Stuck in the lab without a window even. And I was wondering if you have like a special spot on campus that we can go birding that you see, or is it just walking in between classes, or where?
It's kind of hit or miss. So this week I've actually walked every morning this week looking for window strikes. So it's been kind of hit or miss finding where the bird flocks are. It's like today it was like a little mini flock up by Beckman. There's like 3 bay-breasted warblers and a few redstarts and the black-throated green and stuff. But yesterday the only flock I had was all the way down like by the education building on the far side, south side. So, and then like Tuesday, I found a Cape May warbler. Is the only warbler I had on the whole quad was a Cape May warbler. So it's just kind of been hit or miss.
I think it's probably going to pick up soon as well. But
That's for sure.
I'm
for
really
sure.
excited for the birding this Sunday.
Yes. It should be exciting. It'll be a lot of birds to see, I'm sure.
Cool. So I'll get started with just some general introductions, give folks more time to join, but I can get started so long. I want to start off by saying that this meeting is being recorded, so just be aware of that. And then let's see. I want to first welcome everybody joining our first or restart after the summer first meeting of Champaign County Audubon Society. My name is Alida de Vlaming, and I am the program chair of CCAS. And I'm delighted to welcome today 3 of the recipients of the S. Charles Kendeigh grants, which is a grant for ornithology education presented through CCAS to research in Illinois. So we have 3 Kendeigh grants participants here today. We have Rachael DiSciullo, Alex DiGiovanni, and Claire Johnson joining us today. And I'm not going to say too much about them because I'm pretty sure you'll know exactly who they are and what type of research they do at the end of this meeting. I do want to highlight some of our upcoming events since this is the first meeting in a while. So we're very excited to offer our Sunday morning bird walks again starting this Sunday. And there are some regulations. We're asking folks to please wear masks outside, even if it's hot. I know it sucks, but just to keep everybody safe, we're gonna ask that people wear masks while birding. However, unlike in the spring semester, you no longer have to sign up to go birding with us on Sunday. We no longer have a limit of people that can join, but everybody that joins should please wear a mask.
Alida,
yeah?
You might want to mention where people meet and when.
Yeah, I was just about to do that, Roger.
I'm
yeah.
sorry.
So we meet. No, I mean, it's good. I definitely will miss stuff, so I appreciate it. So we meet on Sunday mornings at 7:30. And the walk is usually from about 7:30 to 9 a.m. And we meet outside the parking lot at the Anita Prairie Nature Center. And if you want to join us for birding, but you don't have binoculars, you can email me, and I'm sure you can email Colin, and we can arrange something for you, or arrange a set of binoculars for you. So that's our Sunday morning bird walks, and you can also find more information on our website. I'll post the link to our website in the chat once we kick off our talks. I also want to say that our first CCAS board meeting is on September 20th for board members. And then we have the big day in October, which is a day-long celebration of birds this year. And I'll also post, or we also have information of that on our website that you can check out. And I think you can also go to ebird.org, October Big Day 2021, to find more information. And the last thing that I really want to mention is that we're going to have our annual Sandhill Cranes at Jasper Paluski trip. It's happening on the 6th of November, and it's a trip where we go as a group to Jasper Paluski to check out the thousands and thousands of sandhill cranes. And if you've never been, I think it's one of the most magnificent sites out there, and very special, and you should really consider joining us. And I hope I haven't missed anything. If any of the other folks have anything to add, please tell me. And otherwise, let's get started with our Kendeigh grants. And I think the best way of doing this is going in the order that the speakers were introduced in the newsletter. So we're going to start off by with Rachael, and then Alex is going to tell us about his research, and then Claire is going to end it all off for us. And so with that, Rachael, why don't you take it away?
Alrighty, let's share my screen. Okay, so today I'm going to tell you a bit about my dissertation research, kind of the whole story of it, which for the fun talk title, I've given it For Whom Does the Male House Wren Sing? So before I get started, I just wanted to thank you all both for coming today and also to the Kendeigh Grant Committee. You know, these grants are absolutely critical in allowing people like ourselves to complete our theses and dissertations. So thank you very much for this opportunity and for the grant as well. So to tell you a little bit about myself, my name is Rachael DiSciullo. I'm actually originally from Pennsylvania. That's where I did my bachelor's. So I have a bachelor's and a master's in biology. I've worked with a variety of animals leading up to this point, as demonstrated by my little cartoons here, including perhaps in a birding group, most exciting toucans in Costa Rica, which was a really amazing experience. And I studied fish behavior for my master's. And now, of course, I'm studying house wrens here in Central Illinois. Obviously, everyone here is into birds, but I'm not sure of our biology background. So I wanted to start with an introduction to sexual selection, because this really frames my research. Sexual selection is like a natural selection, but rather than traits that enhance reproductive success, traits that enhance mating success are favored by sexual selection. So this can happen in sort of one of two realms. Traits can be intra-sexually selected, so that's within sexes, and that's typically male-male competition. So a great example here would be the enlarged jaws of the Darwin stag beetle. Or traits that enhance attractiveness are favored. The bird of paradise is a really spectacular example. I'm a big fan of a peacock spider. They're adorable and gorgeous. And of course, song is another aspect or trait of typically males that's sexually selected. And no surprise, I'm interested in birdsong. And there's a ton of evidence that birdsong is sexually selected across a number of different passerines. It definitely functions in male-male competition in some species. It can also function in mate choice. It might do one or the other. There's a plethora of evidence that demonstrates that song is important for sex and mating. And the different components of song that are important also vary quite a bit. So, you know, whether song plays a role in male competition or female choice is one question. And the next question is, well, what parts of song matter here? What is particularly sexy to the female or incites aggressiveness in the male? So just a couple of many possibilities include repertoire size. So that's the number of songs a male sings, or perhaps in a complex song, the number of notes he sings within the song. These are different types of repertoires. How much trilling he does is a physically challenging trait, because the bird needs to quickly open and close its beak while inhaling and exhaling. So this is a difficult sound to produce, and to do so rapidly. So that's been demonstrated to be attractive to females. How much song is going on might be the song length itself or the song rate. So how much song is being produced within a short period is also known to relate to both intra and intersexual selection. So there's tons of possibilities, lots of different realms of song that might be selected in birds. And in house wrens, I'm wondering if indeed, we can parse out what these components are, which components of male song are favored by sexual selection. House wrens, you may know, are extremely widely distributed and latitudinally the most distributed of all passerines worldwide. So they're found from northern Canada down to Argentina and the tip of Tierra del Fuego. This is a map of eBird sightings from a couple years ago. So as you can see, it's pretty amazing the spread that they have. It's all one species, there are subspecies, and the northern population of northern house wrens then are migratory. So they spend their winters in the Gulf and they come up here into Canada late April, early May, as you're all very familiar, and breed in the area. The males and females are completely monomorphic in morphological traits. So same brown color, right? Same size. If you have them in your hand, you can check for a brood patch or the cloacal protuberance, but beyond that, you can't tell them apart, except acoustically, they're extremely different. So here I have two spectrograms. Here's an example of a male song. Here's an example of a much less common female song. Some work in populations across the states has demonstrated that females sing with quite a bit of regularity, but their song is much less complex than the males when it is present. And in the population that I study, we rarely see females sing in this sort of repeated note way at all. So there's a lot of variation in this, but what is consistent is that males sing loud, beautiful songs. You likely know the house wren song, but just to acquaint you with some components here, I'm going to show you a spectrogram and play the song at the same time. To acquaint you with a spectrogram, if you've not seen them before, on the y-axis is the frequency of the song, so that's the pitch, and then the x-axis is just time. So I'll go ahead and play it. One exemplar of many. The males are just absolute amazing singers. They sing many, many different types of songs. So this is just one example of one song type. We consider the song to be in two sections. So the first part is the introductory section. That's the sort of bubbly, often quieter component of the song. And then the terminal section is typically louder, and it goes from a high to a low frequency most of the time. And it's a series of repeated trills. So each of these traces on the spectrogram is a note or an element. And when you see elements paired together, we call that a syllable. And then the repetition of that element or the syllable is a trill. I've placed another spectrogram on here just to show you these were two songs produced by the same male in the same recording. So hopefully, as you can see, there are some shared notes across the song, but other notes are unique to the song. So this trill here at the end is only in the second song, but not in the first. So males have extraordinary complexity within individuals, the number of songs that they can sing, and also among individuals. And this has been demonstrated in a population in Canada. They've quantified and qualified the song produced, and also in Argentina. So this hasn't been done very much, but a couple groups have been working on this, including now my group. Interestingly, though, they've not found a relationship, at least in the southern house wren population, of repertoire size with reproductive success, which, if you recall from earlier, that's a common predictor. So a little disappointing, but there's other components to investigate. They produce these trills, right, which are physically challenging. And another aspect that you can make the trill even harder is what pitch the bird is singing while producing the trill. So if they go from high to low in the trill, this is called vocal deviation. It's a physically challenging component because not only are they opening and closing the beak, but they need to inspire and expire, which is just, it's hard. There's a trade-off there. So typically, again, some groups have found relationships in other passerines with reproductive success, and a group in New York found no relationship of this trait with reproductive success in that population. So some work has begun to investigate which components of house wren song are sexually selected, but we've not found any evidence yet of what that component is. We do know, however, that it seems very clearly that it's playing a role. So females are attracted to male song, a study done back in '96, where the researchers placed a speaker at an empty nest box where they played house wren song, pretty near another house wren nest box with no song playing. The females went to the nest box where the song was playing. So she was more attracted to where her conspecific male was singing at. And male song makes the house wrens angry. If you know anything about house wrens, you know that they're a grumpy little group. So work in my lab has shown that males will actually come and attack mounts when you play speaker and with song, and we put a taxidermied skin on the nest box. And we've done this at nests that are active. So the male is there, it's his nest box. And we come in and put a fake wren on there and play the song, and males will often come in and attack that male. And they do so quite rapidly sometimes. So the males are responding as well in a way that you would expect if this trait were to be sexually selected. So ultimately, you know, that has led me to this question of which components are indeed acting in the system to be intra and intersexually selected. All my work is done here in central Illinois. So our study area is about 20 minutes north of Normal, very easy to get to. We drive out in the van every morning, leave at 5 a.m. or sorry, 6 a.m. I wake up at 5. It's not that early. So we go out. The study area is really beautiful. It's accessible at the ParkLands Merwin Nature Preserve. If you guys have ever been over to see the bluebells in the spring, you should absolutely come over. It's a spectacular site. My advisor has been working with this population since 1980 when he started at ISU. So we've got 42 years of data on this breeding population, which is pretty unique in the States. There are a few groups that have been working in the same area for as long as this. So it's a pretty spectacular system. We have 700 nest boxes available to the birds. So this map here on the right, each dot represents a nest box. And at peak occupancy, in the first brood of the breeding season, about 30% of the boxes have a nest within them. So we're banding all individuals, all adults and all babies on the study area with unique numbered aluminum bands provided by USGS, which means that we band about 400 to 500 adults every summer and about 2,000 nestlings. So we're super busy. It's amazing. So that's all in addition to whatever research we're carrying out. And of course, undergraduate researchers are always assisting us in this. Here in my hand is a male. So males are color banded in addition to the silver band that's on his leg, aluminum band that has that unique number. We add a unique combination of colors to the males because they're more difficult to capture. So this way, later on, after we've caught him, we can just check him out with the binoculars, look up his combo and say, oh, okay, that was, you know, male who was born at NG2 in 2017. So we don't have to catch him again because they're far more wily. Okay, so to get back to what I'm researching specifically, so I plan to address my dissertation by tackling these three sort of overarching questions. The first of which is, what song is even being produced in this population? It's, you know, we've been listening to it for 42 years, some of us, but we don't know exactly what components are the songs are composed of. So that's kind of the first step here. The next step for me is to take what I've learned about the song and compare it to proxies for fitness and see if there's a relationship there. If the male sings more of note B, does he have more babies? If he has a faster song rate, does he have more babies? Things of that sort. And then finally, I can actually, because I work with this wild population that is very loyal to these nest boxes, I can go back into the forest and play song to them and see how they respond in the wild to really test the hypothesis, hopefully, assuming that I find a relationship between some song components and paternity, then I can see if the birds respond in the way that we expect them to. So to tell you a little bit more in depth about what I've done so far in these steps, I have all the song collected already. So I have 557 15-minute recordings. Each of these recordings, a male is producing up to 150 or so songs. The songs are about 1 to 3 seconds in length, and they have up to 83-ish components. So those are those notes or elements before. I use this program Raven, which is produced by the Cornell Lab of Ornithology. And I have to go in and individually select each note. So that's what these blue boxes are. That's from me dragging my cursor across the note. But it's amazing because the program is gathering quantitative information about each note, and then I can go in and give it a name. So I have a whole dictionary, which is what my symbol here is for, where I've defined these different notes. So I have descriptive information about them, but also quantitative. So been working on that for a while. It's laborious, as you might imagine. And then when we gathered these song samples, we also took blood from the males and their mates and their offspring. So we have over 1,000 blood samples. And what we'll do with this is we're going to extract the DNA in order to determine paternity. You very likely know that in the 90s, before the 90s, we thought that many birds mated for life and it was lovely, they were paired and it was great. Well, we've learned since doing DNA analyses that actually a lot of birds are cheaters. And my population and house wrens in general are no exception to this. So about 25% of all nests have at least one extra pair young within them. So what that means is that you have a socially paired set of birds, and they're going to work together to raise the babies in the nest. They do biparental care, so each of them are feeding. But at some point, that female accepted a mating event with another male who came onto their territory. So at least one of the babies, sometimes more in that nest, actually were not fathered by the male who's tending to them. So I need to do the DNA extraction and genetically determine paternity. Otherwise, I wouldn't have a true idea of how many offspring he produced, because I need to add the babies he's had in other nests or subtract the ones from his nest that are actually not his own. So this is where the Kendeigh grant comes in. This is a very costly process. And we're doing this in a new way in the lab too. So there's been some extra costs generated with getting everything prepped for sending these samples off to the University of Minnesota, who's going to do the genotyping for us, get all this information, and then I can process it with a free program that allows you to relate the genotypes of each to determine paternity from that. So pretty neat, very costly, but absolutely amazing that this exists and is pretty accessible even to a graduate student. And then finally, I'll do some stats. So there's this very neat multivariate selection analysis tool. It's a statistical tool that's been used in other systems. So it's been used in frogs and in crickets. But to my knowledge, no one's used this type of statistical analysis in birdsong. And it's very powerful. It's much like a correlation. So it's not going to say, okay, definitely song rate means that you'll have more babies, but it will say, okay, if you have a quick song rate, males tended to have more babies, if that's what's true. And what's also neat about it too is that many statistics will only show you directional selection. So if, for example, song rate was important and fast song rate was important, then this type of statistical analysis would capture that, and so would a classic one. But if, say, very low song rate and very quick song rate were important, the common stats that one would use to analyze this wouldn't reveal that. So this looks at multi-dimensional possibilities for what's being selected. So this is really an exciting way to look at these data. And like I said, hopefully it will reveal something. And if it does reveal something, then I can make song on the computer. I've done this quite a bit before by Frankensteining some song together. And again, if that song rate's important, I can make a quick song rate and a slow song rate, and then play it in the forest and see are females coming to visit, are males coming in angrily. And I've done a bit of this before, including this summer. I've done a preliminary study, generated song that isn't, I have no predictions of whether it will attract females or not, but it was generated based in the real parameters of song. And I had a bunch of different exemplars. So I just wanted to show you a little clip of what this looks like, just to acquaint you with what's going on. This is, of course, a nest box. This is a 3D printed house wren. that a lab mate of mine painted. So I know it's a bit of a bad angle, and you'll see why in a second. But what's going to happen here is the first song you'll hear is my playback, the song I made on the computer. And then the second song is a neighboring male. So keep your eye on this guy here. So as I mentioned before, and as you've likely seen, males can be pretty aggressive towards one another. So that was an example of a male who was not happy about having another in their territory. So they do respond. It's very exciting that you can do this work in the field. So hopefully not too long from now, I'll be able to tell you a bit more about what I've found. But in the meantime, this is what I've been working on, and super happy to share it with you all. And I would love to take any questions you might have.
Thank you so much. That was super, super interesting. Yeah, I think it would be a good idea for us to ask questions at the end of each of the speakers. So let's see, does anybody have any questions? You're welcome to type it in the chat box, or unmute yourself and ask questions directly. I have a few questions that I can start with.
Go ahead, Alita.
The first one is just like out of general interest and vaguely related to like your introduction. I was wondering whether you mentioned like some of the females sing, and I know you said the ones where your work is they don't really sing. Mm-hmm. But I'm wondering, is there a correlation between male song and female song? Like, do males sing to females or sing differently to females that sing? Or is that something?
Yeah, that's very interesting. No idea. So the work that's been done was by a group in Michigan, I believe, and it was more about female song generally rather than in the context of sexual selection. So perhaps, but I mean, what I know so far is that the males sing a lot before pairing, and that's been shown in the past as well. So a female, if I should have said too, the ecology of the house wren is that, or the life history is that the males arrive first and build a cup-shaped nest, and then they begin singing. And at some point they've attracted a female, and she will finish the nest with some soft lining materials. So I would imagine that he's not going to sing more to a female that's singing simply because he's singing, apparently anyway, to bring her in the first place. But that would be super fascinating, and I just don't know.
Yeah, I mean, I'd be interested to know, but I agree. So let's see. Megan asked the question. First off, she says, great presentation. How do house wrens learn their song? And as a follow-up question, is there any chance that they could learn or adopt any Franken songs you create and play for them?
Very interesting question. So to the first part, they learn when they're young. So they learn from the time that they hatch and egg. And in fact, there's evidence that embryos are listening to the song in other species, not in house wrens. But this happens very early on in development, that when their brains are developing as they're young, they're hearing the tutors in the area. So what's fascinating, and what I don't know the answer to, is, they're born on the study area and then they leave, right? They migrate to the Gulf and then they come back. And about 5% of babies come back the following year to breed, and about half of adult males. So once you're an adult, you've got a better chance of coming back. About a third of female adults come back. But they come back and then they're singing the dialect of Illinois. And I don't know how that's working when they're down in the Gulf, if they're sticking by the individuals that they migrated with, how they end up singing the song, because there are these different dialects across the states and across Canada. So they're learning in their time as a juvenile. And then beyond that, I don't know how much learning goes on as an adult. So I suspect that they wouldn't learn my Franken song, which I love that portmanteau, thank you. But I'm also not giving them anything that they shouldn't be hearing anyway, because I'm making these songs from my own recordings in the study population. I'm not making up notes or anything like that. This is a song that I have, you know, added trills to, or, you know, took out notes from. And these are typically in orders that I've seen before. Like I mentioned, the complexity is outrageous. They almost have the ability to put notes in any order. So any song that I make does have X% chance of even existing in the population, even when I'm adding and subtracting notes. So I don't think that they would change anything, or at least in a bad way, as adults, but it's certainly possible. Hope that answers your question.
I have another question, but I'll save it to the end because I am sure the other presenters will also get questions, and I'm scared we're running into their time. So next, Alex is going to tell us about, I think you're able to share your screen. We tested that earlier.
All good?
Looks good, yeah.
Okay, hi, I'm Alex DiGiovanni. I am a former member of Mike Ward's lab. I just graduated for my master's, and now I'm in Virginia pursuing my PhD at George Mason University. So today I'll be talking about a little bit about developmental strategies of songbirds in the incubation period. So since birds develop externally, most resources for the embryos that they need to develop is input into the egg before they are laying. Thus, the embryo is limited to what it starts with. Altricial birds, like songbirds, actively incubate their eggs and thus are more in control of their developmental rate of those embryos because they incubate them. And avian embryos are poikilothermic, which means that they require heat for development. And thus, avian embryos are good candidates for studying embryonic development and linking those parental incubation behaviors to the development of the offspring. The incubation stage is a critical period of avian life history. Timing the egg is much more important than just surviving the hatch and can impact factors such as the health and condition of nestlings once they hatch, the growth of the nestlings once they hatch, as well as song learning, like Rachael was saying, which for some songbirds begins in the egg, and which can affect social behaviors and interactions, and that's even reproductive effects later on in life once they're out of the nest. And this incubation period is relatively an understudied period of life of avian life, where there's been a lot of studies on nestlings and fledglings and adults, but relatively few on this incubation period. Embryonic development occurs within an optimal thermal window, and they're outside this window, poor development occurs. So if it's too hot, this could lead to poor nestling condition or growth. If it's too cold, embryonic growth stops, and then they're just maintaining and not really growing anymore. So with either of these can result in poor nestling growth or even death if they're too extreme. And there's evidence that a longer incubation period may produce higher quality young. Now, embryonic development is largely mediated by the parents, and primarily females in the species that I'm looking at. And this includes both the physiological inputs within the egg, such as like the yolk and the hormones, but it also includes the behavioral inputs by the female, such as the duration of incubation, both throughout the whole incubation period, as well as the length and amount of bouts she takes on the nest, and the temperature the clutch is kept, since, like I just said, that temperature is really correlated with development. Moving on to heart rate now, and linking this to temperature, heart rate is linked to it, and thus parental care, because the parents are incubating the eggs, and the embryos require an optimal temperature to develop. So heart rate and development are essentially linked. Embryonic heart rate has been shown to be a good proxy for metabolic rate in several studies, and therefore heart rate is negatively related to the length of the incubation period, as you see in this example here from Vetter et al. whereas the eggs and embryonic heart rate increases, the length of the incubation period decreases. The incubation period has many temporal constraints, with the primary threats to nest success are time-dependent mortality risks, such as predation. So the longer they spend in the nest, the more likely they are to be predated. And then also neotropical migrants are constrained to that breeding window that allows their young to develop before they need to migrate. Also, daily survival rate across species differ with things like nest location. So cavity nesting species are a little bit safer than open cup nesting species. In addition, egg production and incubation are costly. So consequently, these constraints should select for rapid development of offspring to get them out of the nest so that they can escape those predation pressures and successfully be developed for migration. Because it's costly, there's many trade-offs surrounding the incubation period. It could affect things like the quality of young. There could be developmental issues and lower quality nestlings that come with fast growth. It could also affect things like survival, because species with lower survival may benefit from pushing their developmental periods and making them develop quicker so that they limit the time they spend in the nest to escape those predation pressures. There's also trade-offs with the number of eggs in the nest. More eggs means a greater reproductive output possible, but at the same time, there's evidence of females not being able to incubate larger clutches, which could lead to either hatching failure, developmental issues later on once they hatch, and other issues that we will go into later. I have a whole section on this. So there's many different trade-offs between increasing reproduction versus taking care of the eggs you have. So overall, today I'm going to be talking about what factors impact embryonic development within wild altricial species. My first question is, are there species-specific differences in embryonic heart rate? And we'll look into what factors most affect heart rate. And then also, do the incubation behaviors of species differ, and to what extent they affect heart rate? Then we'll go into looking at hatching failure and seeing if there's species-specific differences in hatching failure and what factors affect hatching failure, as well as what stages the hatching failure may occur most frequently. So moving on to part one, incubation and heart rate. So my study sites were comprised of a mix of grassland and shrubland habitats. You may know them: Kennecook County Park, which I'm sure most of you have been and visited. It's a beautiful place, lots of birds there. And then also Jordan Creek Nature Preserve, which is about 20 to 30 minutes northeast of Kennecook, but it's not open to the public. We collected heart rates using a non-invasive ballistocardiogram system. This measures the movement of the heart as the blood is pumped through the embryo. And we did this every 3 minutes for every 3 days. And for those nests that we took heart rate from, we extracted the maximum heart rate for each egg for each sampling period. To investigate incubation behaviors, we use these things called I-button temperature loggers. There's one here. I don't know. Can you see my cursor? I don't know. There's the circle right here next to the cardinal eggs. That's an I-button. We put these in the nest alongside the eggs. And when the female comes to incubate the nest, these temperature loggers log the temperature. And there's a difference in temperatures when she's on the nest versus off the nest. And an example of the output of one of these is right here in this graph here. Where these big dips are like nighttime and daytime, but you can really see when she gets on and off the nest. It really skyrockets when she gets on and then really drops low when she gets off. And then from these data, we were able to extract the amount of time the female spent incubating and the overall temperatures of the nest. We investigated several factors that may affect heart rate, such as egg age, egg temperature, the volume of the eggs, the season or the ambient temperature, which is highly correlated, clutch size, and then nest parasitization status. So whether there was brown-headed cowbird eggs in the nest or not. Oops. I had a wide array of study species: American robins, brown thrashers, common yellowthroats, stick thistles, eastern bluebirds, eastern towhees, field sparrows, gray catbirds, house wrens, indigo buntings, northern cardinals, red-winged blackbirds, tree swallows, and yellow-breasted chats. Just a wide range of a lot of common birds that we can find a lot of nests for, so we had a lot of eggs to use. Moving into a little bit of my stats and models, I don't know if people care about this too much, but I used generalized linear mixed models to look at my data, and then I controlled for nest identity, egg identity, and egg identity within each nest to make sure there's no specific differences of a specific nest or female incubating that may affect our results. And finally, I ranked our models to see which one was describing the variation that we saw the best. Moving on to my results for this section, I had a relatively robust sample size with the greatest number of nests being from field sparrows. That's that really big one there. Overall, we collected data from 456 nests, which included 1,272 eggs. That's a lot of eggs across those 14 different species for my 2 field seasons. Of these nests, 68 of them, or that's about 7%, were parasitized by cowbirds. So we had 2 categories that we were interested in: nest type and parasitization status. So I just want to show you some things real quick about these 2 groups that may be important later on. So we have the cavity nester species in blue here, and then open cup nesting species in orange. There's different differences in whether species get parasitized or if they are not parasitized and reject those cowbird eggs. And then I want to point out that the highlighted in blue cavity nesters had higher clutch sizes, longer incubation periods, longer nestling periods, and then higher survival rates throughout the whole juvenile period. So from when they're laid to when they fledge. As a baseline, here's the trajectory of heart rates for species over time. So as embryos age, so too does their heart rate. And this is consistent for birds in general. There's been lots of research done on this, and I'm just showing here that this is true from what we saw as well. So we used age in our models to make sure that that wasn't conflating any of our results and messing with anything that we were trying to take away from our results, because since heart rate increases with age anyway. So looking at maximum heart rate across species, we see that eastern bluebirds and tree swallows, which are both cavity nesting species, had significantly lower heart rates than the other species. We also see that DiSciullos had significantly higher heart rates, but most of the other species are remarkably similar, despite having differences in like life history traits and size and everything, and what's in the nest and a lot of different things. So it's remarkable that they all had relatively consistent heart rates despite all these differences. As expected, we also saw that heart rate is closely related to temperature, since the embryos develop within the optimal temperature window. And we did indeed see this with our data as well. So then of the factors we investigated, what best explained the heart rate differences that we saw? When comparing these factors that may affect heart rate, we see that the timing in the breeding season best explains these differences. It was our top ranked model, and then everything else, which is like when you pack the whole model with, or one model with all the other effects, that was the next one. So that doesn't really describe very much. So week of season was our top ranked model here. And we also see that heart rate increases across the breeding season. So we have a week of season here on the bottom. So this is like mid-April, and then this is the ends at August 1st. And as summer goes on, heart rate tends to increase even when we control for age of the embryos. We also see that the average heart rate is negatively related with daily survival rate, where those species with a greater likelihood of surviving have lower heart rates. And we also see this negative relationship in the length of incubation period and heart rate, where those species with longer incubation periods also have lower heart rates. And note that for both of these comparisons, here in the most extreme areas are cavity nesting species. So we have house wrens, tree swallows, and bluebirds here. And over here we have bluebirds, tree swallows, and then the last one over here is also a house wren. Looking at the incubation periods then, we placed these 137, eye buttons and 137 nests, different eye buttons, across 13 different species. And then we looked at the 3 hours before we took the heart rate readings to be able to look at how the behaviors of the female impacted the heart rates that we collected. So for those species with greater variability in their nest temperatures, they had lower heart rates. And remarkably here, the eastern bluebird, the cavity nesting species, the only cavity nesting species we did this with was way out here with high variability in their nest temperatures, whereas everything else, all the cup nesting species were clustered here on the right with lower variability in nest temperatures and higher heart rates. If we relate nest temperature variation to other life history traits, we also see a positive relationship where those species that are more likely to survive have more variation in the nest temperature. And we also see that those species with longer incubation periods also have more variation in their nest temperatures. And in both cases, we see that the cavity nesting species, the bluebird here, they're much more different than the open cup nesting species. So here we have survival rate with nest temperature variation. So those bluebirds have much higher survival rate, but they also are much more variable in their nest temperatures. And here we have incubation periods, like I explained a little bit earlier. The bluebirds, the cavity nesting species, have a longer incubation period, but they also have higher variation in their nest temperatures. So in summary, looking at the heart rate part of my talk, we see that heart rate differed across species. We see that cavity nesting species have lower heart rate, and there's a similarity in the heart rate of most of the other species, the open cup nesting species. We saw that week of season was the best factor that we tested that explained heart rate, and we saw that heart rate increased across the breeding season. We saw a negative relationship between daily survival rate and heart rate, and most notably in the cavity nesting species, which have safer nests and also lower heart rates. And then finally, we saw that nest temperature variation was negatively related to survival and incubation period, where those cavity nesting species show greater variability in nest temperatures. So what does this all mean? We see that there may be different strategies across species, where the cavity nesting species have a slower strategy development, whereas the open cup nesting species may have a faster strategy of development. We saw that there was some seasonality, which may be due to be adaptive across the breeding season to potentially ensure that their young get out of the nest with a decent chance of surviving. Overall, it seems that cup nesting species with more predation pressures are trying to push developmental times to shorten their exposure periods, while cavity nesting species are taking their time and pushing their limits to have greater reproductive outputs. Okay, now moving on to part 2 of hatching failure. While we were finding nests and using the heart rate monitors on them, we started to realize that there was a surprising amount of eggs that failed to hatch. So we decided to investigate this and what might be the cause of this great rates of hatching failure, and at what stage this was occurring. Was it occurring right before the hatch, like in this picture here of a bluebird, or was it really early on in incubation? The cost of producing and incubating an egg is relatively high for a female, so to see these great rates of hatching failure was quite surprising. Hatching failure can be mainly due to two like categories. One of those is internal causes, and this could be due to poor genetics, poor internal provisioning, so there's not enough yolk or some weird anomaly with the hormones, or it could also be due to environmental contaminants and infections getting inside the egg. It also could be due to some external causes, such as clutch sizes, if that affects the female's ability to incubate the eggs, brood parasitism, which can affect the parental incubation behaviors and nest temperatures, and then the incubation trade-offs of females in their nest attendance. One potential reason for hatching failure could be due to infertility. However, we saw that there's a few studies out there, several studies actually, that have looked into this, and they actually reported low rates of infertility with a range of from 70% all the way up to 99% of the hatching failure that they saw was actually due to mortality and not infertility. So as a reminder, here are the questions for this section. Are there species-specific differences in hatching failure? Specifically, what factors are affecting hatching failure? And then at what stages is it occurring? The different factors that we looked at that may be affecting embryonic mortality was nest parasitization, which may change incubation behaviors and nest dynamics, nest type, so like cavity and open cup nesters, clutch sizes, since it may be difficult to incubate larger clutches, daily survival rate of the species, since how safe a nest is may affect the incubation strategy and behaviors of the incubating parents, and then finally, incubation behaviors, looking at the nest temperatures, since extreme temperatures can cause embryonic mortality. We determined if an embryo had failed, if it remained in the nest after the other eggs had hatched, and we used the heart rate monitors on them and they didn't have a heart rate, or there was no heart rate for 2 of our nest checks, which spanned, so that would be at 6 days at the least, and there was no developmental differences when we candled them from the first nest check to the second nest check. So we're leaving them in the nest for a real long time. If there's no developmental differences, we say, okay, they're probably not developing anymore. And oftentimes we would see when they stop developing this on the bottom here, where we see the embryo and like just a bunch of yellow and not really much going on here. Whereas this top one here is an example of what a developing embryo would look like, with a bunch of like veining going on, and you can see them moving around and their hearts beating and everything. So we dissected a total of 94 eggs in the 2020 that we collected from the 2020 field season. So looking at failed eggs, we saw that species differed in their likelihood of having a dead egg in their nest, and then as well as the number of eggs that failed in their nest. We also saw that egg hatching failure ranged a lot, from about 1% to 12.3%. And so we saw a lot of these percent of failed eggs happened in bluebirds, house wrens, and another big one was yellow-breasted chats, but not to leave out tree swallows and indigo buntings. We also saw that nests with failed eggs also range from 0% where the whole clutch survived versus 33%. So here are all of the 94 eggs that we dissected in the graph here on the right. And we first aged these embryos to their exact incubation date using since we know that birds lay an egg a day, and if we found the nest when they were laying or when they were building, we knew exactly where they were in their laying cycle, and we knew how old they were. But if we didn't catch them in that time, we could also count back from when they hatched, since we know how long it takes for them to hatch. So to mitigate any potential error with that, we binned them into different groups. Day 0 of incubation, we called undeveloped. Day 1 to day 4 of incubation, we called early. Day 5 to day 8, we called mid incubation, and then day 9 to when they should have hatched as late incubation. 36 of our 94 embryos, or about 38%, ceased developing at the earliest stage in our undeveloped category. We also saw that hatching failure was more common in the earliest age group, and it did not vary across the later 3 stages. And then we also saw that stage-specific rates of hatching failure did not differ across species. Then next we looked at nest type. We saw that cavity nesting species had a greater percentage of hatching failure, or almost 12%, than open cup nesting species, which was just over 6%. We also saw that cavity nesting species were more likely to cease developing earlier in the stages, whereas we did not see any difference when we in our dissections for the open cup nesting species in the age at which they failed. We also didn't see any association between hatching failure and nest temperatures when comparing nests with and without the failed eggs in the days prior to when they ceased developing. So we limited the data to when before they ceased developing based on our aging criteria. And if this is happening, it would be more likely to see all the eggs in the clutch fail rather than just one, and which was rare in our system. We only had 6 nests or about 1% of all the nests we found where the whole clutch failed to hatch. We also saw nest temperature variance here in the graph on the right, differed across species, with eastern bluebirds here up at the top having significantly more variable temperatures than other species. But there was no relationship with nest temperature variation and hatching failure. We also saw that there was a positive relationship between daily survival rate of nests and hatching failure across all species. Thus, nests with higher survival rates tended to have greater rates of hatching failure. And then we also saw that large clutches had greater likelihood of having a failed egg in the nest, so which is this graph here. So those clutches that are small had small likelihood of having a egg fail to hatch, whereas those nests with larger clutch sizes were much more likely to have an egg that failed to hatch. Because of their change in nest dynamics that cowbirds add when they lay their when they parasitize a nest, we thought that they could be a source of some of this hatching failure that we saw, but this did not hold true. We didn't see a greater likelihood of eggs hatching in or eggs failing to hatch in parasitized nests. We also saw a few cowbirds themselves fail. We only had 5 eggs in the course of our 2 field season of 5 cowbird eggs that failed to hatch. So in summary, we saw that failure was more likely with species with higher nest survival and higher in greater nests with greater clutch sizes. We did not see any evidence of nest temperatures causing failure and no evidence of extreme nest temperatures causing failure as well. We didn't see factors of cowbirds causing more hatching failure. And then the failure that we did see was more likely in the earlier stages of development rather than the late stages. And this is especially true for cavity nesting species. So what are the implications of the hatching failure part of my talk? Cavity nesting species are maybe pushing the reproductive limits in terms of the number of eggs that they're laying, even though there might be a cost and benefit between laying all these eggs and incubating them, where there might be a trade-off here between the species which are more likely to be safe versus get predated, where those that are likely to be safe may be able to lay those more of those eggs and have that reproductive output, even though, or as opposed to the open cup nesting species, which are more likely to get eaten. So they don't want to lay all these eggs and waste all those resources. Another reason that we could see these patterns could be due to the long exposure period of cavity nester eggs between when they lay their first egg and when they initiate incubation, which is usually with the second to last egg they lay. So those eggs that are laid first or second in something like a house wren may have to wait 4, 5, 6 days for full incubation to occur, versus something like a cardinal where they only lay 2 or 3 eggs and they only have to sit there for a day or 2 before they get that full incubation occurring. And then finally, there may be something going on with the way that the different nesting species like cavity nesters versus open cup nesters value their eggs because of the reproductive outputs that they could have. The cavity nesting species since they are much more likely to survive, they also may value those eggs more since it has a higher chance of making it. So bringing it all together, our results link together what later life stages, such as egg, nestling, and fledgling stages. There's been a bunch of research on this, and we're just kind of linking it here at the end with the incubation period of these specific strategies that species may take to produce their young. There have been many studies on these later stages, but little has been done on this stage of this incubation stage of avian life history. While what we've done is the first step, now there's much more work to be done. We've seen that in our study around 8% of eggs fail to hatch, which is not a trivial amount. And there appears to be different reproductive strategies that species are taking, where species with safer nests are taking maybe a slower approach to life with longer incubation periods and lower heart rates. Whereas on the other hand, those open cup nesting species, which might be in a much more hurry to reduce the time their offspring spend in the nest, such as dick thistles and field sparrows, since they're much more likely to get predated and have a larger chance of not making it to and surviving. And with that, I'd like to thank all my funding sources, especially Champaign Audubon Society, and I will take any questions.
Thanks very much, Alex. So we have time for a quick question, and I have a few questions, but I'll save them to the end, since I don't want to take up too much time, since it's already 8 o'clock, and I'm scared folks might have to leave soon. But we have time for a question if anybody has a specific question, urgent question that they're dying to hear the answer to. If not, then Claire, why don't you take it away, and then I'll save the questions, Alex, till the end. Or I guess I can ask you one while Claire is setting up. What eggs were those that you had in your hand in the implication slide?
Those were house wrens.
They're smaller than I expected for some reason.
They're very tiny.
Sorry.
No worries.
Okay. All right. Cool. All right. Well, thanks everyone for staying on a little bit late. I'm excited to talk to you about some of my research. So my name is Claire Johnson. I just finished my master's degree at the University of Illinois. I got to work with Alex a little bit. So I graduated in May. I studied the ecology of black and yellow-billed cuckoos. And today I'm going to be talking about part of that research, but focusing on where did the cuckoos go? So we found evidence that these birds are moving long distances during the breeding season, and also discuss a little bit of their habitat associations. So both of these species primarily breed in North America. Yellow-billed cuckoos have a more eastern distribution. Their population numbers are estimated at about 8 million individuals right now. Black-billed cuckoos have a more northern distribution, breeding up into Canada. And they're greatly outnumbered by yellow-billed cuckoos by about 10 to 1. So current population estimates are at about 800,000 individuals. Unfortunately, both of these species are suffering significant population declines. So since the 60s, yellow-billed cuckoos have declined by about 50%, and black-billed cuckoos by almost 70%. So here in Illinois, we're really at the southern edge of their breeding range. They're not very numerous, and given that they're suffering these great declines, they were listed as threatened in the state of Illinois in 2009. So they're of special management concern in the state. But unfortunately, in spite of these declines, we don't really know what's causing them. For one thing, their habitat associations are poorly understood, making it difficult to manage for these species. So a lot of yellow-billed cuckoo research has focused on southwestern populations. There are these little isolated pockets over here. I do think I read that Audubon actually helped protect some tracts of land for the western yellow-billed cuckoo, which is really great. But as you can imagine, this kind of cottonwood riparian habitat is pretty different from what we have in the eastern United States that encompasses the majority of their breeding range. There's really not a lot of studies done on black-billed cuckoos. A lot of what we know comes from observations only, or is using meta-analyses on broad-scale surveys like the Breeding Bird Survey, which some of you might participate in. And so one reason for this general lack of information is that these species are really difficult to study. So good job me for choosing them as a study species. But as I'm sure some of you know from being out in the field, they're both really secretive and difficult to detect. They have really low call rates. Yellow-billed cuckoos are estimated to call at a rate of about once an hour. In our research, we've found that black-billed cuckoos are much less vocal. So they're hard to detect using vocal cues. They also tend to be sit and wait predators, so they hold still in dense foliage most of the time, making them really difficult to see. So when I started my project, I wanted to address some of these barriers. So specifically, what affects detection probability of these species, and what does this mean for how we survey for them? So are there more effective methods for surveying for cuckoos? And also, what are their habitat requirements during the breeding season? So we selected 41 sites on public lands in northern Illinois in these 7 counties. I had never really, I grew up in Illinois and I had never really explored the forest preserves up in like McHenry and Lake County, and they're really cool. So if you're up there, I suggest visiting some of them. And so at each of these sites, we selected a transect of up to 10 points, depending on the size of the area. And then we visited each of these up to 3 times during the breeding season. And we conducted a passive survey where we just stand to look and listen for cuckoos. And then we followed this up with a broadcast survey where we play species-specific calls over a small speaker. And this is a pretty common method of increasing responsiveness of birds. So from that first, sorry. So we also measured some vegetation variables around our survey points. So looking at things like number of trees, canopy cover, shrub cover, etc. So in that first year, we found that broadcast surveys make a huge difference in responsiveness. We were expecting this, but I didn't think it would be such a huge magnitude. So black-billed cuckoos were 12 times more likely to be detected using broadcast surveys, and yellow-billed cuckoos were 6 times more likely to be detected during surveys. So this graph is showing detection probability of black-billed cuckoos specifically. We see that detection increases slightly with temperature, but there's this much bigger effect of survey type. And I also want to point out that passive survey, regardless of environmental conditions, is really low. It's about 10% maximum for this species. For a lot of other species, passive detection is about 30% or more. So to me, this is saying that passive surveys are really not effective for figuring out where these really secretive birds are. So that was great, but unfortunately, our habitat associations were still inconclusive from this first year of data. So again, this is for black-billed cuckoos. We saw that they were slightly more likely to occur in areas with greater shrub cover. But looking at these confidence intervals, this is really not what you want to see. So these large light gray bars aren't very conclusive in this relationship. So while broadcast surveys are really effective, one of the problems is that they can pull animals away from the habitat that they're actually using towards the speaker. So to get around this, we want to measure habitat where they're actually foraging or nesting. And so this is where the Kendeigh grant funds came in. They let me buy transmitters and some banding equipment in my second year. So we were able to buy new mist nets, which was a great thing. There's nothing worse than having a holey and tangled mist net. And when we got these smaller radio transmitters as well. And so I was focusing on catching black-billed cuckoos only, since they're the less studied of the 2 species, and they're also threatened in Illinois. And this is a really exciting part of the project. I liked going out to all the different sites doing broadcast surveys, but getting to catch and handle the birds and see them up close is really, really rewarding. So we'd go out early in the morning. My crew did a great job, even though we had some frustrating days of catching no birds. We'd set up our nets and try to hide behind whatever shrubs were available. When we caught cuckoos, we would put the radio transmitters on them. We'd also take measurements like wing length and tail length and assess general body condition. And we would also put a uniquely numbered metal USGS band on these birds so they could be identified if they're captured again. And we put color bands on them so we can recite them in the field and know what bird we're looking at. So this is going pretty good. We started tracking birds. We use these antennas and receivers. And this, as we get closer to the bird, the signal gets stronger. And we were doing a pretty good job of getting through these kind of dense shrubby areas. It also made it a lot easier to find nests. So we found 2 birds with active nests. We found a 3rd bird. We captured it a little bit too late, but it had a fledgling with it. So that was really exciting to see that they were successfully breeding in our sites. So everything is going great. And then we started to lose signals on these birds. So this is kind of a window into the difficulties of doing field work. We had one bird we never relocated after we tagged it. A couple others left just a few days after we put transmitters on them. Those that had active nests, or the bird with the fledgling, did hang out for a little bit longer. But as you can imagine, I was extremely frustrated in the field. We put a lot of time and energy into catching these birds, and they were disappearing with our transmitters. So I was like, Claire, you're wasting these grant funds. But it's important to remind myself that no data is still providing useful information. So the fact that we were losing signals on these birds is telling me that they're kind of dispersing in the middle of the breeding season out of these sites, which is not a common behavior. Again, so like these birds are leaving and flying at least 10 kilometers away in the middle of June, which is nowhere close to when they would be migrating. We also found that they tended to move around a lot while they were within our sites. So they're using these large home ranges. So within a single day, birds were moving on average 130 meters between tracking bouts. So we would go out every 2 to 3 days to track these birds. We would relocate them about 250 meters apart. And so here, again, we didn't have enough data to do home range analyses, but I'm showing the what's called a minimum convex polygon. So we're basically connecting the farthest apart foraging observations of these birds. And we can see that they're kind of ranging over a pretty large area for a bird this size. So we found this evidence that black-billed cuckoos were moving a lot, both within their home ranges and dispersing out of their home ranges during the middle of the breeding season. And I also knew that from talking to another woman studying yellow-billed cuckoos that she had found a similar pattern. She had GPS transmitters on her birds, so she was able to see where they're actually going. But some of them were moving up to 100 kilometers away from their original banding location in the middle of the summer. And it didn't seem like they were moving south to migrate. So this is really weird. But this ultimately helped us kind of change our final analysis of our data. So we, using our occupancy data from broadcast surveys in my 2 field seasons, we used what's called a dynamic occupancy model. And so this is basically allowing us to figure out the probability that a bird is going to leave or move into an area between our 3 survey rounds that we were conducting during the breeding season. And this is it's really important to account for this movement if we know that it's happening, because it enables us to get a better estimate of detection probability. So you can imagine that detection probability would be estimated lower than it actually is if a bird we're not detecting a bird that we think is there, but it's actually left. So we're not able to detect in the first place. And similarly, this also improves our ability to get at habitat associations. So using this larger data set, we did find strong evidence of within season movement of both species. And so this is kind of average probability rates of each species moving around during the season. So this is maybe a little bit confusing, but we estimated, we had a high estimate, about 90% probability that cuckoos would leave a point between our survey rounds. So that's kind of showing that they're moving within a transect, so they're using a large home range area. We also find that they had a high probability of leaving a site in the middle of the season. So going along with them dispersing out of their sites. And we kind of saw a similar pattern for yellow-billed cuckoos. So given evidence of that these birds are moving around so much during the year, this kind of suggests that conservation might need to be coordinated at a broader scale. So rather than focusing on protecting and creating habitat at individual sites without talking to other forest preserves, maybe we need to make sure habitat's available across the state for these birds to use. We weren't able to measure insect availability, unfortunately, but I do think that this is playing a big role in what's causing these birds to move around during the season. We know that both species really like these eruptive caterpillars, so things like tent caterpillars, fall webworms, and even invasive gypsy moths. And so by moving around, they're kind of able to exploit these ephemeral, patchily distributed resources. Just as a side note, cuckoos are also kind of unique in that they prefer these spiny, noxious caterpillars that a lot of other birds kind of avoid because they're poisonous and they're covered in spines. So that's kind of a cool thing about these species. Maybe more importantly, by accounting for these within season movements, we were able to get a better idea of what habitat these birds were using. So black-billed cuckoos were using areas with a better developed shrub layer within a more open landscape, so consistent with them preferring a younger successional habitat. On the other hand, yellow-billed cuckoos use areas with young trees, but that were old enough to kind of start shading out the subcanopy. So there was a sparser shrub layer, indicative of them using older successional habitat. So given that they're both disturbance-dependent species, this suggests that loss of early successional habitat is contributing to their declines. So in the past, the landscape was a lot more heterogeneous. We had some like riparian waterways, patches of forest and hedgerows. But as I'm sure many of you are familiar with in Illinois, as agriculture has intensified, we've lost a lot of this habitat to corn and soybeans. So again, having shrublands on the landscape is really important for cuckoos. I think this habitat type is really undervalued by the general public. Even I, up until recently, kind of thought of shrublands and, of grasslands and forests as being kind of like higher quality habitat, and like poo-pooed this transitional habitat type. But shrublands are really productive. They produce a lot of insect and fruit resources that are used by other species. Forest and grassland birds come into these shrubby areas to forage, and they're also really important in providing cover for young fledglings that would otherwise be exposed to predation. So I think shrublands are really cool. Hopefully that's one takeaway for you from this presentation. Again, I want to thank Champaign County Audubon Society for providing me with funding to carry out some of this research. I also appreciate all these other organizations that provided funding or access to their land. I want to thank my advisor, TJ Benson, my committee, and all the other folks that helped me in and out of the field. And I'll take questions now or later. But again, thank you so much for listening, and thank you for helping me with this research.
Awesome. Thank you very much, Claire. Cuckoos are one of my favorite birds ever. So weirdos. So if you have a question, you're welcome to either type it in the chat box or unmute yourself and speak directly to the speakers. If nobody has urgent questions, I'll start with the ones that I have. Let's see, I wanted to ask you, Claire, when you all caught these cuckoos, since they're so difficult to catch, right, and so elusive, did you take any other samples, any biological samples that can be used for genetic analysis?
We did. So we took feather samples to sex these birds because I was interested in which birds were leaving, especially since we had active nests, and we had, so those nests were still active when those birds left the site, which was interesting. And so actually it's been found that sometimes yellow-billed cuckoo females, once their eggs have hatched, they'll sometimes abandon that nest and start a new nest with another male. So that could have been what was going on there. And then we did collect a blood sample. So Mark Hauber, who loves bird parasites, is interested in sequencing their genome. Their phylogeny isn't totally resolved. So he'll be working on that. That'll be exciting. Yeah, good question.
Yeah, I had a question. What happens to those young cuckoos when the adults move away?
Well, hopefully we didn't. So we went back to those nests a couple of days after we lost those birds, and there wasn't a sign of predation. They were still alive. So like with the yellow-billed cuckoos that I mentioned earlier, the male is hanging around, and so in these species, both male and female are incubating and also feeding the young. So he kind of takes on those responsibilities. So hopefully they're still making it to fledging.
Cool, Alex, I had a question for you, and you might have talked a little about this, and I might have missed it, but you mentioned at some point species survival goes up with variation in temperature, and I was wondering why. I think you showed a graph that said species survival on the x-axis actually increases as temperature variation in the nest increases, or I might have missed something.
Hold on, let me see if I can share my screen again.
It was one of the slides where I think you mentioned there are other factors or other trends as well.
This one?
No, it was a line graph, but I guess this could also work.
I didn't, yeah, so, yeah, I don't remember what graph you're talking about specifically, but so like, we didn't see that temperature had any effect on whether they survive or not. Is that what you were asking me?
Oh, I thought I had heard that species survival goes up as temperature variation goes up, but I am definitely in the wrong if that's not something you all found.
Species survival. And so you're not talking about hedging failure. Just
No.
I don't think I said that. No, sorry. I mean, so there, as the season progresses, their heart rates are going up, and then, but temperature-wise, we didn't see we saw temperature variation highest in cavity nesting species, which tend to have higher survival. So maybe that's what was happening.
Cool. I also have a follow-up kind of question in general, but if anybody else has a question, please interrupt me. Otherwise, I'm just going to continue asking all my questions. The other question I had is, and this is like a vaguely related question to your work, but I'm sure you get asked this all the time, is the impacts of climate change on your species. So is that something that anybody has looked at? Like, are there physiological responses in embryos that change in areas, or that change more in areas that are experiencing more severe climate change?
I don't know if anybody's looked at that. I didn't, in my research when I was doing like a review, I didn't see anybody doing anything with climate change, although maybe I just missed it because that wasn't totally my focus. So I mean, there could be something out there, but I would think that it would definitely impact the like incubation behavior, because if it's hotter out, the females might be able to take more bouts because it's hotter out, so their egg temperatures don't drop as dramatically or as quickly or whatever. So that might impact some of their incubation behaviors. That might impact things like predation rate if they're getting on and off the nest more because they're allowed to now. Temperature's greater outside. Now that might impact predation rates because they might get predated more because they're getting on and off. So they're like telling the predators where the nest is. I could see that affecting behavior a lot.
Alita, my lab mate is actually looking into this for her master's. So if you hang out and see in a year or two when she publishes, with the wrens, of course. So predation is obviously lower in that case, but she increased the temperature actually in some of the nests within the expected range of increased global temperatures, and it's looking at incubation and the effect on nest success. So she's not finished analyzing the data, but this experiment is done. So maybe it'll be published in 9 months, 10 months.
Maybe we can convince her to come give a talk.
Yeah, there you go.
Oh, and since I'm talking to you now, I had this is the last question I have, I promise. But Rachel, I was wondering, you mentioned that you all are doing genetic analysis. Are you considering looking at like specific things in addition to just like paternity? Are you looking at specific fitness genes, or is that a little beyond what you had in mind?
Definitely beyond. That would be super neat. I don't even know what I would begin to look for. I mean, we have morphological data of the nestlings, so I have that sort of proxy of their success. And then of course, because we're tracking throughout their lifetime, I have grand offspring, which is like, you know, the gold standard, right? So, but yeah, just DNA.
Fair. I think that's a very fair thing. Do any of the other participants have any other questions?
Alex, I have a question. Are the birds, so like a lot of the cup nesters with lower survival, are they more likely to double brood to kind of make up for the fact that they suck at reproducing?
Yeah, if they are successful, you're saying? I
Or either way.
I don't know if I would say they're more likely to double brood. I think it just, like bluebirds double brood, and they might even be able to triple brood because they start so early. So I don't know if that's really playing a role. I mean, I'm sure they try. I'm like, you know, a lot of the cup nesters that like in the grasslands and stuff will definitely, if they succeed with one, they'll try again if they have enough time, if it's not too late in the season. But I don't know. I don't have any data or anything to prove that like they're more likely to.
Okay, cool.
Cool. Well, if nobody else has any questions, I want to remind you that this talk is recorded and we're going to post this talk on our YouTube channel, which we also have, and we'll also share a link to the recording with all of the speakers, but also with you through, I think we usually share it either through social media or the bird notes. And with that, thanks again to all the presenters. This is super interesting. Thank you for taking the time to tell us about your research.
Thank you for having us. This is great.
Thanks.
Thanks, everyone. Have a good night.
Yeah, thank you. Good night.
Thank you all.